Right, so today we're talking about, we're going over section 6.3, and we're going to be kind of building on what you did in GeoGebra with the points of concurrency. But instead of just looking at the images and creating them in a geometry software, you're going to be actually using the characteristics of the points of concurrency to solve some math problems. So first thing that we're going to talk about, circumcenter. This is something you absolutely need to put in your notes, pretty much this entire diagram, so you can make sure to understand the math that's going on. So the circumcenter, in this picture, the circumcenter is point P right here in the middle, is equidistance from the vertices of the triangle. So that means that the distance from the circumcenter to each of the vertexes, which are A, B, and C, the points of the triangle, the distance is equal. So this distance is equal to this distance, which is equal to this distance here. And we mark it with that little line. That little line in geometry means that those lengths are the same. The other thing that you need to remember is the circumcenter is created by the perpendicular bisectors of the sides of the triangle. So this side right here, ADB, the way that we got the point, let me label it right here for us. Our circumcenter is this point right here in the middle. And the way that that point was found was by finding the midpoints around the outside and then drawing a 90-degree line from those midpoints. And this is a characteristic that you want to make sure, because not only do you get information about the lengths of these parts of the image, but because the circumcenter is created from the perpendicular bisectors, we also know that this length right here from A to D is the same as the length from D to B, because D is the midpoint. It's bisecting AB. Same with from B to E, that distance is the same as E to C, because that line was bisected by this line that was created, that was used to create the circumcenter. And then the last one, this line down here at the bottom, AF, is equal to FC. So the circumcenter gives you a lot of information about parts of the triangle, parts of the picture that are equal to each other. And you need to make sure you understand, if you're given the circumcenter, what pieces you can make connections to, what pieces are equal to each other. All right. Now the second point of concurrency that we're going to use today is the incenter. Now the incenter, again, that's this point right here in the middle, point P. Maybe we're going to change that to I for incenter. But you're going to want this diagram on in your notebook as well. So the incenter is equidistant from the sides of the triangle. So notice that the incenter, it has these lines drawn that go from the incenter to each side, and they connect at a 90-degree angle, which is important. But if the point is the incenter, then this distance, and this distance are all equal to each other. Those are all equal distances. And the way that you create the incenter is by bisecting the angles of the triangle. So angle A over here, this angle, if it's cut in half, that's how you got this line that connects for the incenter. But what that tells you is that this angle is equal to this angle because it cut angle A in half. It also cut angle B in half. So this angle is equal to this angle. And for angle C, the two halves are equal to each other. So we get a lot of information from knowing that this point in the middle where they're connecting is the incenter. It gives us very different information than the circumcenter. So you're going to have to use these details to help you solve math problems going forward. So for example, in the figure shown, here's a triangle, ND equals 5x minus 1. So the length N to D, so that means this piece right here, that distance is 5x minus 1. Now what I do when I do these problems is, as it gives me information about my picture, I add that to my picture. So I would put 5x minus 1 right there because it tells me that that's the length of that piece. It's not a number, it's a equation. Well, I guess it's an expression, but it still gives me that distance. And then it says that NE, so this distance is 2x plus 11. So I'm going to put that as well, 2x plus 11. I'm going to add that to my picture. And then it tells me to find NF. It wants me to find this distance right here, what that distance is. So that's my question mark. All right, when I look at this picture, there's a couple of things that I notice. I notice that this red line right here is cutting angle A into halves. And I notice that this red line is cutting angle B into equal parts, and this red line is cutting C into equal parts. That means that this point right here, because all the angles are getting cut in half, that point right there is the incenter. So N is located at the incenter. Knowing that that is the incenter gives me more information. It tells me that this length right here is equal to this length right here, which is equal to the length that I'm looking for. So those three lengths are all equal to each other. I want to write that down. 5x minus 1 is equal to 2x plus 11. And those are both equal to my question mark, right? The one that I'm looking for. So I'm going to go ahead and use this information to figure out, first of all, what x is, because then I can figure out the length of my side over there. So I'm going to do some railroad track stuff. I'm going to subtract 2x over here and get 3x minus 1 equals 11. Then I'm going to add 1 to move that over there. So 3x equals 12. And then I'm going to divide by 3 so that I know x is equal to 4. Now, x is 4. Please don't tell me that this length is 4 because that length isn't x. All I know right now is that x is 4. But I can use that to figure out what this length is or what this length is. So if x is 4, if I know that that's true, then 5x minus 1 is 5 times 4 minus 1, which is 20 minus 1, which is 19. So this length is 19. And because this was the incenter, this length is also 19, and this length is also 19. So now I know NF. NF is 19. And guys, this is how a lot of the rest of chapter 6 is going to go. It's going to give you a diagram, and you are going to have to problem solve your way to a solution. You're going to have to use the picture. You're going to have to pull information about the picture and use it to solve problems. And they're not all going to be the same. It's not always going to be the same steps. You're going to have to use some of your own reasoning and deduction to figure out what problem, what you need to do to solve the problem, okay? So this one, number 4, in the figure shown, QM equals 3x plus 8. So QM is where? QM is right here. So that distance is 3x plus 8. And I noticed that it's at a 90-degree angle. Okay. QN is 7x plus 2. So QN, that's this distance, is 7x plus 2. And it wants me to find QP, this distance. So this kind of looks like the last one, but I want to check a couple of things. First of all, I don't know what this point is yet until I look a little bit more at the problem. Like, look at angle K right here. It's getting cut in half, and I can tell because of this line and this line tells me that that angle is being cut in half. Angle L is also being cut in half because each of those has 2 red lines. So that means this point right here is made up by cutting the angles in half and finding where they meet, which tells me that that point is the incenter. Now I know enough information to do some math with it because the incenter is the same distance from the sides of the triangle. So that means that this length is the same as this length, which is the same as the length that I'm looking for. So 3x plus 8 is equal to 7x plus 2, which is equal to the side that I don't know. So I'm going to railroad track, figure out what x is. I'm going to minus 3x. I'm going to minus 3x. So 8 equals 4x plus 2. I'm going to minus 2 over here. 6 equals 4x. I'm going to divide by 4. So x equals 3 halves or 1.5. All right. So now that I know what x is, I can figure out the length of one of these 2 sides. Let's go ahead and do this one, the 3x plus 8. So 3x plus 8, but x I know is 1.5. So I'm going to plug that in. 3 times 1.5 plus 8. 3 times 1.5 is 4.5 plus 8 is 12.5. So this length right here is 12.5, which means this length right here is 12.5, and that means this length is 12.5, which is what I was looking for. Okay. All right. We're not going to worry about that problem. Homework problems. 3 through 6 and 11 through 16. So not a lot of homework problems. Just, what is that, 9 homework problems. But you're going to have to do some deduction. You're going to have to do some reasoning to solve the unknown parts of the triangle. So as you're going through these homework problems, use the information that it's given. Like on number 3, it wants you to find BG, and it gives you information. It tells you that the perpendicular bisectors intersect at point G. Well, that tells you something about the sides of the triangle. It tells you something about G, which tells you something about the distances to the corners. But you're going to have to work through that. It doesn't give you all that information. You have to work your way through and make sense of it. Let me know when you need help.